A digital platform defines a rule where certain user decisions create irreversible states. Once a choice is confirmed, reversal is no longer available, and the system visibly marks this permanence. This establishes a structural condition where timing of commitment directly determines future flexibility. Because access continuity is tied to maintaining these irreversible states, remaining within the system becomes the dominant reward. Losing reversal is framed not as a penalty event, but as a permanent loss of optionality. Users begin to treat early decisions as gateways to preserving access rather than evaluating outcomes. A user encounters an early decision point before full system information is available. The cost of delaying is not immediate, but the cost of committing incorrectly becomes irreversible. The system shifts decision logic from accuracy to timing, tightening the window for evaluation. Instead of optimizing for best choice, users optimize for avoiding irreversible loss. The visible state of commitment signals that waiting carries hidden risk. This pushes decisions forward in time, even when information is incomplete. What appears to be proactive engagement is actually defensive positioning against lock-in. The system does not require better decisions, only earlier ones. Behavior reorganizes around minimizing exposure to irreversible states. A single early commitment reduces the need to revisit future decisions. This lowers immediate cognitive cost, but accumulates long-term constraint. Users trade adaptability for continuity without direct comparison. The system reinforces this by making committed states stable and uninterrupted. Access continuity becomes smoother for those already locked in. Uncommitted users face increasing uncertainty, widening the gap between states. It seems like stability is achieved through consistency of use, but consistency is not driven by satisfaction. It is driven by the cost of reversal. The system stabilizes behavior without requiring positive outcomes. Each new decision inherits the constraint of the previous one. Options narrow not because alternatives disappear, but because switching becomes structurally costly. The decision space compresses over time. Users begin aligning future actions with past commitments to avoid conflict. This creates a path-dependent sequence where deviation becomes increasingly expensive. Behavior converges toward maintaining internal consistency. The system does not enforce this alignment explicitly. It emerges from the accumulation of irreversible choices. Control shifts from system rules to historical commitments. At first glance, users appear loyal to the platform, but loyalty is not the driver. Exit cost is. Retention becomes a byproduct of constrained movement. Even when better alternatives exist, switching requires abandoning prior commitments. The loss is not just functional, but structural within the system. Users remain within suboptimal configurations. The pattern scales as more users enter early lock-in states. New entrants observe stable behavior and interpret it as optimal choice. Early commitment becomes normalized as a default strategy. The system benefits from reduced volatility in user behavior. Predictability increases as fewer users deviate from established paths. Adaptation slows, but stability increases. What looks like user preference is actually constraint accumulation. The system does not need to persuade. It only needs to prevent reversal. Behavior becomes a continuation of prior states rather than active choice. Attempts to change direction occur less frequently over time, not because alternatives disappear, but because the cost of change compounds. Exploration declines as commitment deepens. The system gradually transforms decision-making into maintenance behavior. Users no longer evaluate options, they preserve position. The original incentive shifts from choice optimization to access preservation. This creates a stable but suboptimal equilibrium. Users remain engaged, but within paths defined by early decisions. The system sustains continuity by limiting reversibility rather than improving outcomes. As more decisions become irreversible, the time horizon of each choice extends beyond its original context. Immediate decisions now carry long-term structural consequences that cannot be reevaluated later. Short-term action begins to define long-term position, tightening the mismatch between decision timing and outcome relevance. The system does not delay consequences. It defers visibility of those consequences. Users commit under conditions where future constraints are not fully observable at the moment of decision. Information about long-term lock-in remains incomplete, increasing the probability of premature alignment. Each early commitment becomes a reference point for subsequent decisions. Instead of reassessing options independently, users evaluate new choices relative to existing commitments. This creates a chaining effect where each step reinforces the previous one, reducing the likelihood of divergence. The accumulation of irreversible states introduces a structural inertia into the system. Even small misalignments cannot be corrected incrementally because reversal is not available. Adjustment requires abandoning the entire chain, raising the effective cost of correction. At scale, this behavior compresses variation across users. Different starting conditions converge into similar commitment paths because early decisions are made under the same constraints. The system produces uniform behavior not through preference, but through synchronized lock-in. This uniformity feeds back into user perception of available options. When most visible behaviors reflect locked-in paths, alternative strategies appear less viable or less tested. Exploration is not only costly, but also informationally disadvantaged. A feedback loop emerges where reduced exploration limits new information entering the system. With fewer deviations, the system generates less evidence of alternative outcomes. Users continue committing early because the system no longer surfaces credible alternatives. The platform stabilizes around this reduced informational diversity. Decisions become easier to make quickly because fewer options are considered relevant. Speed of commitment increases, reinforcing the original lock-in mechanism. Over time, the system shifts from decision-making to position maintenance at scale. Users operate within predefined trajectories rather than evaluating fresh options. The distinction between choosing and continuing collapses. However, this stability introduces a structural fragility. If initial commitments were misaligned, the system amplifies that misalignment over time. Correction remains possible in theory, but becomes impractical in execution. A tension appears between stability and adaptability. The system efficiently preserves continuity, but does not guarantee alignment with optimal outcomes. This raises uncertainty about whether observed stability reflects success or constraint accumulation. Despite this uncertainty, behavior does not adjust. The cost of testing alternatives remains structurally higher than maintaining current positions. The system continues reinforcing existing paths regardless of their quality. As more users operate under the same constraints, the lock-in dynamic becomes self-sustaining. New users inherit a system where early commitment is already the dominant strategy. The mechanism no longer needs reinforcement. It is embedded in the system structure. The equilibrium strengthens as irreversible states accumulate across the user base. Each additional commitment reduces the overall flexibility of the system. Adaptation slows further, consolidating a stable but constrained behavioral landscape. At this stage, system behavior no longer depends on new decisions being optimal. It depends on previous decisions being maintained. The system persists through continuity of commitment rather than quality of choice. The system no longer rewards evaluating options at the moment of choice. It rewards entering irreversible states early enough to preserve access continuity. Delayed decisions are not rejected explicitly, but they carry a higher risk of losing future flexibility. Previously, behavior could adjust as new information emerged. Now, adjustment is structurally penalized because reversal is no longer available. Future actions are constrained by past commitments rather than current conditions. What the system ignores is the accuracy of any single decision. It does not correct misaligned choices once they are locked in. It only preserves the continuity of those choices over time. The result is a stable pattern where users act early to avoid irreversible loss. They maintain existing positions even when better alternatives exist. Behavior converges around preserving access instead of optimizing outcomes. In this equilibrium, the system does not need to enforce decisions directly. It only needs to maintain irreversibility as a condition of participation. Behavior continues along fixed paths because the cost of leaving them remains structurally higher.